Okay, here are the MAT 1140 notes. These are pages 3 and 4. So I have two different situations. We're going to define transversal. So a transversal is a line that intersects two or more lines at different points. So in this case, here's the transversal. Here's the transversal. Okay. It's the second one that we like better because fabulous things happen when the two lines are parallel. In the left example, that line is cutting two lines. They are not parallel. It is still called a transversal. The angles still have the same relationships, but special things happen when the lines are parallel. So first off, vertical angles, which we defined up above. Vertical angles are the angles that are opposite an intersection when two lines intersect. So on the left-hand side, it's 1 and 4. On the right-hand side, it's 1 and 3. On the right, also 2 and 4, 5 and 7, 6 and 8. I am not going to highlight all of them because this will get really messy as we go through. So vertical angles are the angles formed across, opposite, across from each other when two lines intersect. Angles are corresponding if they are in the same place. So take a look at the example on the left. When that transversal intersects line A, angle 3 is in that bottom left corner. When it intersects line B, that's angle 7. Okay. On the right-hand side, I'm going to use angle 4 and angle 8. Angles in the same position. When a transversal intersects two lines. Now, back up a second. We know that vertical angles are always congruent. Doesn't matter what's going on with the other lines. When the two lines are parallel, then those angles are the same side. So same size. Sorry, corresponding angles this is somewhere else, are congruent when transversal intersects two parallel lines. I will start writing smaller. Next, alternate interior angles. So the interior angles are the angle on the inside of the two lines being cut. So 3 and 6 are alternate interior angles. Over here, it's 3 and 5. Also 4 and 6. These are the angles that are inside the two parallel lines. and on opposite sides of the transversal. And I'm going to abbreviate over here, alternate interior angles are congruent, same size, when the transversal cuts two parallel lines. Again, with our not parallel lines, these are still alternate interior angles. We just can't say anything about the size of them. Alternate exterior angles, same thing as what we have above. So these are angles outside. I guess I should highlight. Let's see. Alternate exterior. So 2 and 7 are alternate exterior angle. Outside the two parallel lines, opposite sides of the transversal. So over here, we'll use 1 and 7, even though 2 and 8 are also alternate exterior angles. And on opposite sides of the transversal. And then we got the same thing over here. Alternate exterior angles are congruent when the transversal, and I'm going through these quickly. Identifying them is what's important in the homework, not these properties. But they're out there, so I figured we'd cover them. Now we have same side exterior angles. Two and 8 here, same side exterior. 2 and 7. On this one also 1 and 8. These are angles outside the two parallel lines. And on the same side of the transversal. Same side exterior angles are supplementary, so they add to 180. And I know I'm going through this quick. Same side interior, we can figure out what this is going to be. On the same side, in between the two parallel lines. So 4 and 5 over here, also 3 and 6. So these are the angles on the inside of the two parallel lines. And on the same side as of the transversal. Same side interior angles also add to 180. And there's that. Other thing the homework's going to ask you to do is convert from degrees, like degrees with decimals, to something called degrees, minutes, and seconds. So our clock, hours to minutes, minutes to seconds, is a base 60 number system. 60 seconds in a minute, 60 minutes in an hour. And here are hour, and I'm using air quotes, which you can't see, is our degrees. Okay, so symbol-wise, degrees, minutes, seconds, and they'll always be given to you in order. Nobody's going to try to trick you and put these into some different order. Okay? So notice for A, it's got 47 minutes. And look up above. I've got no degrees. I'm not worried about that. I need minutes divided by 60. That's going to give me a decimal. That's going to be a number less than 1. 0.7833 degrees. So this is how we get rid of a decimal part of a degree, or we make it more precise. So for B, I've got 10 degrees plus 18 over 60 minutes, plus we divide 15 by another 60. That gives us 3,600. So divided by 60 divided by 60 is the same as divided by 3,600. Here we get 10.30416. So to 4 places, we're going to go 3042. For C, I have no degrees. I have 5 minutes and 15 seconds. And when we divide those out, we should get a number less than 1. We get 0.0875. That's degrees. When we want to go back the other way, we're going to do the opposite of what we did. So if I have seconds, I'm going to multiply it by 3,600. If I have minutes, I'm going to multiply by 60. And actually, I'm going to go minutes first and then seconds. We'll pull the minutes part out, see what's left, then pull out the seconds. So let me show you what I mean. So here, I'm going to take my 0.35, and I'm going to multiply it by 60. When I do that, I get 21. So by multiplying by 60, I'm converting this decimal to minutes. This gives me 2 degrees, that was the whole number part, and 21 minutes. And the going back and forth takes a little bit. Okay. So B, I have no degrees. I do have this 0.12, which I'm going to multiply by 60. It's going to give me 7.2. Okay, now, the 7 is my minutes part. So this is 7 over 60. This 0.2, I'm going to multiply by 60 again. I've already multiplied by 60 once. So I don't need to multiply by 3,600. I've multiplied by 60 once. I've multiplied by 60 again. It gives me 12. So my whole number part here is my minutes plus my whole number part here is my seconds. Yeah, I shouldn't write it the way I just did. Again, 0 degrees, because we did not have any degrees to begin with. So let's try this again. 0.3149. I am going to start by multiplying by 60. When I do that, I get 18.894. The whole number part is my minutes. That's what I got when I multiplied by 60. Now I'm going to take my 0.894, multiply by 60 again. Keep in mind, I have already multiplied by 60 once, which is why we're not multiplying by 3,600. We're just multiplying by 60 twice. And I get 53.64. Now, these are my seconds. We don't like decimals with seconds. Or our directions here say round to the nearest second. So I've got 18 minutes here and 54 seconds. That 6 means my 3 rounds up to a 4. So again, no degrees for each of these. Do have minutes and seconds though.